So we're going to spend Monday, Tuesday, Wednesday covering 7-2, doing more practice. So once I go through examples, the more practice you guys do, the easier these are going to become. At the beginning, when you first are doing these, it's a bit challenging, but eventually you're going to get the hang of it. So there are 19 examples in these notes here. I will not get through all 19 today. My hope is to get to number 11, and then I'll finish up the rest tomorrow. You have 7 problems for homework tonight. It is not on WebAssign. It is a PDF. Remember, the answers to these problems are your work, and it's the work that it's going to take to get it to simplify down. So we have a quiz on Friday. The quiz will cover 7-1 and 7-2. More of the things from 7-1 would probably be where it asks you to factor it. And then more of the simplifying would be the 7-2. So let's go ahead and take a look. Again, this second slide, these are going to be the identities that you're going to use to verify. So really all we're doing is simplifying. So again, just like before in 7-1, we are not going to use the even-odd identities or the co-function identities. We will be using the Pythagorean identities, be able to manipulate them, be able to rearrange them. For example, for that first one, sine squared x plus cosine squared x equals 1, be able to solve it for sine or cosine. So then you can do a substitution. We'll also use these reciprocal identities, which are these 3. And then remember tangent and cotangent, these were called quotient identities. So nothing new here. We're still using the same identities. We're still going to be adding and subtracting, multiplying, dividing, and different things like that. Now over here on the right side of this slide, these are tips that you can use for verifying or for simplifying for that matter. Now, you don't necessarily have to do them in this order. What we're going to be doing here in the notes today is we're going to take a look at the problem and decide which side looks more complicated. And then that's going to be the one that we're going to simplify down to the one that maybe looks like it has less work. Then if you have to factor something, you can factor it. I know it's not listed here, but you may need to add, find common denominators. You may need to divide, and it's going to be like a key flip change. You may have to multiply. Another tip would be to change everything and write the problem in terms of sines and cosines. Here's where our quotient identity and our reciprocal identities would come into play. And then the last hint here, use Pythagorean identities when needed. So that's where you would do a substitution. Now what's not listed here, and I'm actually going to do an example of this, is verifying using a conjugate. So that's what we're going to also do as well. So let's go ahead and take a look at our first example. Have this little reference sheet handy, whether you have it written down, whether you import a picture of it into your homework, just so you have a quick little reference to help you jog your memory as you're doing these problems. My more complicated side, I know it's hard to see here, the writing's in white, but I think we can see it if you're looking at it on your iPad screen. My more complicated side here is the left side. Now, one thing that you may want to do is, so my first one, I can take a look here. A lot of times when I see a square, I'm thinking I might want to try to do a Pythagorean identity. And that's what I'm going to use for my numerator. However, not for my denominator. Okay, so for the numerator, I'm going to use a Pythagorean identity. And the Pythagorean identity I'm going to use is going to be tangent squared x plus 1 equals secant squared x. Now, when I showed you this before, remember, be able to manipulate this. So what I'm going to do is subtract 1 from both sides, and I get tangent squared x is equal to secant squared x minus 1. Notice this looks like this. So I can substitute now, and my new numerator becomes tangent squared x. For my denominator, you could probably try, and again, this is trial and error. So at first glance, you may think, I may want to try to use the same identity and replace the denominator with tangent squared x plus 1. But if you take a look to the right side, I'm trying to get it to sine squared x. So by using an identity for the denominator, just isn't going to help me. So what I'm going to do instead is I'm going to use a reciprocal identity for my denominator. Remember that secant squared x, or just secant x, let me just go ahead and write it like that way first. Secant x is equivalent to 1 over cosine x. However, if it's got a square, you can also add it to the reciprocal identity. So I'm going to change my denominator and make this 1 over cosine squared x. Now remember, this fraction bar means division. So really what we're doing here, and you don't need to necessarily show this, but let me show you over to the side. So really what this is saying is tangent squared x divided by 1 over cosine squared x. If you want to put this into your solving process, you can. I'm going to go ahead and just jump to the reciprocal. So really what this means is we keep the tangent the same, change it to multiplication, and then flip this upside down. Now I'm going to use a quotient identity for tangent, and I'm going to change this into sine squared x over cosine squared x. I still have this. And now notice I can simplify diagonally. The cosine squared x's become 1s, and then sine squared x times 1 is just sine squared x, and then 1 times 1 in the bottom is just 1. So now I'm left with sine squared x, which is what it wanted me to verify it to, or simplify it to. Fix that. So the answer to your problem is all of the work here that it took to simplify it to that other side of the equal sign. Let's try the next one. It's a little simpler. Pretty good on number 1. All right. Okay, so for number 2, when I first look at the numerator, I'm thinking, hey, wait a minute, that looks like an identity that I know. If you recall, sine squared x plus cosine squared x equals 1. So I'm going to substitute 1 for my numerator. And I'm also going to change my secant squared x to its reciprocal, because I know that secant squared x is equal to 1 over cosine squared x. So I'm going to change the numerator to a 1. I'm going to change the secant squared x to its reciprocal. And now I can simplify the denominator. These become 1s, and now I'm left with 1 over 1, and 1 divided by 1 is 1, which is what it wanted me to simplify it to. So this one was pretty easy. You just used a Pythagorean identity, and a reciprocal identity, and then you multiplied. Now, keep in mind, some of the more complicated ones, there's more than one way to solve them. So there's not necessarily one strict way that you have to follow. Some of the more simpler ones, there's only one way. But some of the more complicated ones, and there's actually one in the notes that we did 2 different ways. I think it's number 4, and I'm going to show you both ways. So let's go on to number 3. So for this one, I'm going to use the quotient identity for tangent and the reciprocal identity for secant. My more complicated side is the left side. So I'm going to change my numerator into sine x over cosine x. And my denominator, I'm going to use the reciprocal identity. And I'm going to change that into 1 over cosine x. So again, remember this division bar or fraction bar means division. So we're going to do a keep, flip, change. Keep the numerator the same. And then flip the denominator upside down and multiply. I can simplify diagonally. And it simplifies to sine x, which is what they wanted me to get it to. And I'm done. Now for number 4, I'm going to do it 2 ways. I'm going to do it distributing it, and I'm also going to do it using an identity, just to show you that there was 2 ways to do number 4. This one, there wasn't a whole lot we can do other than the quotient identity and the reciprocal. Let's try number 4. Now, the first time I do this one, I'm going to distribute the sine squared x. So I'm going to distribute it to the 1, and I get sine squared x. I'm going to distribute it to cotangent. And now what I'm going to do is change cotangent into its quotient identity. So I'm going to leave the sine squared x's alone. Change cotangent into its quotient identity. Notice I can simplify diagonally here and make this a 1. And now I'm left with sine squared x plus cosine squared x. And this is a Pythagorean identity because I know that sine squared x plus cosine squared x equals 1. And that's what it wanted me to get to. So this is one way. Let me show you another way without distributing and replacing the parentheses with an identity. Let me come over here to the side. So let's say instead, let me rewrite the problem. 1 plus cotangent squared x. So if you recall, there's a Pythagorean identity that states that 1 plus cotangent squared x equals secant squared x. I'm going to replace that. So sine squared x. Is that right? No, that's cosecant. Sorry. Let me fix that. This is cosecant. So then I'm going to replace this with cosecant squared x. Then I'm going to use a reciprocal identity, which is 1 over sine squared x. Let me rewrite that one. Notice this will simplify diagonally, become 1s. It'll simplify to a 1, which is what it originally had, equals 1. So either way on this one. So that would be one where I could quickly show you that you could do it either way. So I'm going to simplify my left side. So for this one, I need to try to figure out how to get it into two terms. You know what? I could also do the other side as well. But let me show you both ways where you might have to pull something apart. So for this one, I am actually going to use an identity for the numerator. So the identity I'm going to use is sine squared x plus cosine squared x equals 1. I'm going to move over the cosine. Sine squared x is equal to 1 minus cosine squared x. So that's what I'm going to replace my numerator with. Now, for this one, I need you to think backwards. Think of this as being the answer to something you've already subtracted. So I'm going to work backwards and show you what the subtraction problem originally looked like. So I'm going to change this and I'm going to give 1 its own denominator of cosine. And then I'm going to give cosine squared x its own denominator of cosine. So this is what it looked like before I subtracted. And then this was the answer up here to the subtraction problem. Now, the reason why I did this is look at what I'm trying to simplify it to. I'm trying to simplify it to two separate terms. So now I can simplify the yellow, and then this is just the reciprocal, which is secant. And then for the white, I can simplify and take 1 cosine out of this one and 1 out of this, and I'm left with cosine x, which is what they wanted me to simplify it to. Yes?
So, the cosine x as the denominator gets canceled out since you divided by cosine on both?
Yep. Now, we could have actually worked with the right side. So just to show you, we could also have done this. So let's say instead I wanted to work with the right side. I could turn this into its reciprocal. And now I need to find a common denominator. And my common denominator is going to be cosine. So this one's already got it. This one needs it. Cosine x, cosine x. So when I multiply it, I get this. And now when I add this, this is actually an identity, and it's this up here. So then I can substitute sine squared x for the top, and then it's simplified to what the left side had. So on this one, either way you could have gone, because they're both kind of complicated. So this would be an example you could have chosen either side to simplify. In the homework tonight, most of the questions have a more complicated left side. I had some students earlier in the day who said number 2, they simplified the right side on number 2. Again, as long as your logic is good, that's fine. So for the most part, the left side on the 7 problems that you have for homework tonight are the more complicated side. But again, on number 2, you could do either way. All right, let's try number 6. Now, this is the one where it's a little different. Now, in tonight's homework, you will not have to multiply anything by a conjugate. That's what we're going to do to solve this one. if you recall back from rationalizing the denominator when there's a square root, or even getting rid of the imaginary, remember the letter I? Remember we could never ever leave the letter I in the denominator? This is sort of similar. When we multiplied to get rid of I, we multiplied by its complex conjugate. And what we did for that was we made it opposite sign. So the conjugate for this problem is going to be the opposite sign of what's in the denominator. So let me rewrite what's here. I'm going to simplify the left side. And I'm going to multiply the top and the bottom by the conjugate, which is secant x plus tangent x. This is the conjugate for this denominator. Now, somebody in last period said, well, could we do the other side? Could we do the right side? I tried. It didn't get us anywhere. So you're better off working and multiplying by the conjugate. Now, technically, this conjugate here, when you have anything divided by itself, this is equivalent to 1. So really, all I'm doing is multiplying my problem by 1, but it's going to change it. Now, when I multiply something by its conjugate, I need to FOIL this. But when I FOIL it, outer and inner are going to cancel. So whenever you multiply something by its conjugate, all you really need to do is first and last, because the outer and the inner are going to cancel. Now the numerator I also have to multiply, but 1 times anything is just itself. So the numerator just becomes secant x plus tangent x. My denominator after I FOIL becomes secant squared x minus tangent squared x. Now, the whole reason behind this conjugate, whenever we do this, whenever we multiply something by its conjugate, it should produce a Pythagorean identity that we can use. And this one it does. So the Pythagorean identity that I just created in my denominator is actually tangent squared x plus 1 equals secant squared x. And if I move over the tangent, I now get 1 equals secant squared x minus tangent squared x. So I'm going to simplify and change the denominator to a 1. Yes. Yes. So now I'm left with secant x plus tangent x. And it's a 1 in the denominator, so I don't need to write it. And remember, this is what it wanted us to originally set it equal to. So I'm done. So the goal behind multiplying by a conjugate is to turn it into a Pythagorean identity that you can use to simplify. Let's try number 7. For this one, my more complicated side is going to be the right side. I'm going to be finding a common denominator. My common denominator is going to be both 1 minus sine x and 1 plus sine x. Let me set it up for both. And now let me go back and see what each fraction is missing. So the first fraction is missing the 1 plus sine x. So whatever you're going to multiply to the denominator, also do to the numerator. And then same thing here. 1 minus sine x, 1 minus sine x. Now that you have a common denominator, what we're going to do is add the numerator. So I have 1 plus 1, and I get 2. But then when I go back to add the signs, sine x plus negative sine x, these cancel. And I still have my denominator here. The next thing I want to do is, because look what I'm trying to get to. I'm trying to get to 2 secant squared x. I am going to FOIL the denominator. The denominator, these are conjugates. When I FOIL it, it's going to turn into the difference of 2 squares. My outer and inner are going to cancel. So again, all I really need to do is first and last, because outer and inner will cancel. If you need to see it, let me just show you. So when I do first, I get 1 times 1 is 1. If I do outside, I get plus sine x. When I do inside, I get negative sine x. And then last gives me negative sine squared x. So these cancel. So now I'm left with 2 over 1 minus sine squared x. I know this is a Pythagorean identity. So again, just to show you, sine squared x plus cosine squared x equals 1. I can go ahead and subtract sine squared x. And cosine squared x is now equal to 1 minus sine squared x. So that's what I'm going to substitute. And I know the reciprocal to cosine is going to be secant. So now I can make this 2 over 1 divided by secant squared x. Divide this, keep flip, change it, and it becomes 2 secant squared x, which is what, if I put it back, 2 secant squared x. It verifies. All of these problems will simplify. They will all verify. Again, it's just going to be trial and error. Let's try number 8. Number 8 is the same thing, except for its cosine. So let's try 8. Number 8, I'm going to do the same thing. I'm going to find a common denominator. It's going to be both 1 minus cosine x and 1 plus cosine x. The first fraction is missing the 1 plus. And the second fraction is missing the 1 minus. So 1 times 1 plus cosine x is just 1 plus cosine x. And the same thing here, 1 minus cosine x. Next, I can add my like terms in the numerator. So I'm just going to add the 1's. 1 plus 1 is 2. The cosine x's cancel. For my denominator, I'm going to FOIL it again. Again, it's like multiplying by its conjugate. So all we need to do is first and last. So then this gives me 2 over 1 minus cosine squared x. Again, I'm going to use a Pythagorean identity to simplify that denominator. So again, the Pythagorean identity is sine squared x plus cosine squared x equals 1. I'm going to move the cosine over. Sine squared x equals 1 minus cosine squared x. And I get 2 over sine squared x. Again, I want cosecant And the reciprocal to sine is cosecant. So what I can do is this becomes 2 over 1 divided by cosecant squared x. Keep flip change it. And I get 2 cosecant squared x. And that's what it was trying to make me set it equal to. And it's done. For the next one, I'm going to use 2 Pythagorean identities and do a substitution. So for the first one, remember you have this identity, tangent squared x plus 1 equals secant squared x. So that's what I'm going to replace here. And then the second one, I'm going to rearrange this one. Sine squared x plus cosine squared x equals 1. I'm going to move the 1 over. Sine squared x plus cosine squared x minus 1 equals 0. And I'm going to move the sine over because my goal is to isolate this. So I'm going to move sine squared x to the other side. So now the identity I'm using is cosine squared x minus 1 equals negative sine squared x. So that's what I can replace here. Oops, wrong spot. I need to write it up above. All right, so that's what I'm replacing there, and it's negative. Now what I can do is turn this into its reciprocal, which is 1 over cosine squared x. This one I'm going to leave alone. And now I can multiply. And this is the quotient identity. It's equivalent to tangent. So negative tangent squared x equals the same thing, because that's what it wanted me to get it to. Let me try 2 more. Again, if it helps you to have these Pythagorean identities already rearranged, you can do them ahead of time. If you're really quick at just manipulating, you don't have to do that. All right, let's try number 10. I'm going to do the same thing. Both of these factors are Pythagorean identities. So for the first one, this identity, again, is the tangent squared x plus 1 equals secant squared x. So I'm going to replace, I'm going to move this over. So I'm going to replace this with tangent squared x. And then the same thing on the next one. I'm using this identity again. And I can move over the 1, sine squared x minus 1 plus cosine squared x equals 0. And then to isolate just this, I'm going to move over the cosine. So sine squared x minus 1 equals negative cosine squared x. So that's what I'm going to substitute in here. And now I can again use my quotient identity, make this sine squared x over cosine squared x, multiply it by the negative cosine squared x. This simplifies. And left behind is a negative 1 now. And then -1 times sine squared x is negative sine squared x, which is what it wanted me to get it to. And one last example. It's pretty simple on this next one. Pretty good. All right, number 11. For this one, I'm just going to change tangent into its quotient identity and cosecant into its reciprocal. Tangent becomes sine x over cosine x, and then cosecant becomes 1 over sine x. The sine x's simplify. I'm left with 1 over cosine x, which its reciprocal is secant. And I'm done. So we'll stop here, and then I'll do examples 12 through 19 tomorrow. So you have 7 problems for homework. Again, it's a PDF. It's not a WebAssign assignment. Look for the more complicated side. In most of the problems, you can just simplify the left side, make it equal the right. However, if on number 2, if you think the right side's more complicated, you can do that one as well. So that is it. We'll continue on with this tomorrow and Wednesday. Again, the more you do, the easier they become. We have a quiz on Friday. That's it.